The left, right, trapezoidal, and midpoint rule approximations were used to estimate the following function going from 0 to 2, where f is the function whose graph is shown. The estimates were given here, and the same number of subintervals were used in each case. For part A, we want to find which rule produced which estimate. So let's first designate our subintervals. So let's say here we go from 0 to 1 and then 1 to 2. And then we're going to go ahead and then create 4 subintervals. So here are our subintervals. And the first thing that we're going to do is we're going to go ahead and start off with the left approximation. Okay, so we're going to create these left. So starting where the function starts, here at the top, we're going to create this first rectangle that represents the left. Okay, and then again from here, we're going to go over to the next interval, and then the next one. Oops, let me go ahead and change that there. All right, so then there's the next one here, and then there's the next one there, and therefore you can see what the left one estimates. So you can see here that the left is going to overestimate on this particular function. So we're going to go ahead and write L4 here because it's 4 subintervals and we're looking at the L4. So now we're going to go ahead and draw the estimate for the right approximation using the green. So starting at the right side of the function, we're going to go to the first subinterval. And there is our first rectangle. And then here, we're going to go to the next subinterval. And then here, we're going to go ahead into the next subinterval. And then again here, we're going to have our next subinterval. So as you can see here, that the right is going to underestimate. So that looks like it could be the smallest of the particular approximations. So I'm going to put this all the way over here and call this R4 on this side. Okay, so now the next thing that we want to do is we're going to take a look at the midpoint rule, and then we'll go to the trapezoidal rule. So the midpoints, remember, are going to be in the middle. So we have our midpoint here, 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 and then here. Okay, so let's go ahead and use the midpoint. All right, so if this is the midpoint, that means it's going to start here, and then we're going to have a rectangle right through the midpoint. Okay, another one, here's the function, and then there is our rectangle for the midpoint. And again, here is the midpoint for there, and then we have our rectangle there. And then there's the midpoint there, and then we have our midpoint there. So you can see here that this midpoint, okay, is going to be a little bit more than the right. So it's going to be greater than the right, but not greater than the L4. So we can see here that we're going to write then the midpoint over here because we know it's going to be greater than the right endpoint. Now let's take a look at, again, we use the blue for the midpoint. Now let's go ahead and take a look at the trapezoid. Okay, so for the trapezoid, we're going to use the purple. Okay, so if we go up and then go to the first function and then create our trapezoid for the first one, and then there is our second trapezoid, there is our third trapezoid, and then there is our fourth trapezoid. So the trapezoid is going to be a little bit above that function. It's going to be less than the L4, but it's going to be greater than the midpoint and the right estimations. So we know it's going to be less than L4, so we're going to have the trapezoid with the 4 subintervals here. Okay, so now the last thing that we need to take a look at is the actual function. So looking at the function, which is this integral here, we can see that this is the function and it is concave up. Now, the estimation is a little bit below the actual trapezoidal rule, but it is greater than the midpoint and the right estimates. So that means that here is going to lie where the function is. And so now we can compare. So we know that the left approximation is going to be the greatest. And then the trapezoid is going to be greater than the function. We know that the function itself is going to be greater than the midpoint. And we know that the midpoint is going to be greater than the right approximation. So, in fact, for any function that is concave upward, in this case this is concave upward, okay, it can be shown by the following. We would see that the left endpoint subinterval is going to be then greater than the trapezoid subinterval, okay, and then greater than the function, greater than the midpoint, which is then greater than the right approximations. So now we can go ahead and then assign which one represents which. So we know that L4 is going to equal the largest estimate of these, which is 0.9540. Okay, and then we know that the next one is the trapezoid. So the trapezoid is going to be the next value, which is 0.8675. So T4 is 0.8675. And then the midpoint is going to be the next value, which is 0.8632. And then the right is going to be the least, which is 0.7811. So let's go ahead and move on to part B. So part B says, between which two approximations does the true value of that function lie? Well, notice that the midpoint, M4, okay, is going to be less than the function, which is then going to be less than the trapezoidal approximation. So what are the numbers? Well, we know that M4 is 0.8632. And we know that the trapezoidal estimation is 0.8675. So therefore, these are the two approximations that it would be in between.